Talk about the final exam, and I'm going to have to close Keynote, reopen it. Final exam. This one is Monday at 1:10. Double check that, but I'm pretty sure that's accurate. Yep, Monday at 1:10. So Monday, 1:10 p.m. to 3 p.m. Exam will be about 10 questions, designed to take about an hour. You have the full 2 hours to complete the exam. Okay? So that shouldn't be a time pressure thing. Exam will be minimal programming. At most, one question will be a programming question. The other 9 will be dealing with theory stuff. Okay? So what I want to do is I want to go through our slide set here and talk about things that I deem to be important, and then beyond the slide set, what things might make their way onto the exam, to kind of give you a focus on what to study. Another thing I'll point out is State Farm here is going to be proctoring the exam. I'm going to be in Philadelphia. My grandfather died yesterday, so I have to leave tomorrow, go to the funeral. I won't be back till Monday night, but I will be here for my Tuesday finals. So sorry about that, but people die. it's a thing, you know. It's what are you supposed to do? Oh yeah, there's gonna be cheesesteaks in Philadelphia. And my grandparents are originally from Philly. They were retired down in Florida, so he died in Florida, but they had to ship him up to Philadelphia for the funeral. Is that like weird? That's what they're doing. They're putting him on a plane in a box and shipping him, right? Yeah. But I tell people, at least he went out on top. You know, he wasn't rotting away in a hospital. He was, got up yesterday morning, went to breakfast with Grandma, came home, talked to his 2 daughters on the phone, took a nap, didn't get up. So, we figured this was going to be his last Christmas anyways. Sucky thing is, well, sucky anyways, but he was going on a cruise next week with my grandma and my parents. It's going to be kind of his last hurrah. So, missed out on that guy. What are you going to do? Okay, so I won't be here for the final, but I'll be back that evening. So if you have questions or something like that later in the week, feel free to ask. But you will still have the final here at the correct time, and he's giving it to you. I mean that in an inappropriate way.
You're going to bend over and you're going to take it.
Recording.
Oh.
See, what I said was phrasing. What you said was not.
Just don't say a name.
Caruso? Oh, good.
You can't hear everyone else's what everyone else is saying on the.
Well, he's pretty close though.
I don't think it'll be clear what he said.
Really? I can repeat it.
All
right. What's up?
I kind of want to know what he said because I didn't hear.
Oh, you didn't hear it?
It's variably inappropriate.
Yeah. I don't know. It was all garbled to me. I'm not used to inappropriate speak. So. All right. So, certainly history of Bitcoin, when it came about, how it came about, the idea of this kind of the backstory of this Satoshi Nakamoto person, group, whatever. We don't know who that is or what that is, but person still exists, and they still have a bunch of Bitcoin out there, and there's always an overarching concern that if he spends all his Bitcoin or moves a lot of Bitcoin, it could really affect the market price. I think he has something like 50 million Bitcoins that are under addresses that are known to be under his control. So we don't know who he is. Slow start like all cryptocurrencies. Certainly know about some of the stumbling blocks, Silk Road, and I guess more recently Silk Road 2. So the underground black market stuff dealing with Bitcoin, people selling weapons and I don't know, drugs and nukes and I don't know what other stuff they're selling. Stuff.
Blank
Yeah.
dollars.
You buy all your your current your bleached dollars from them.
No, I sell them.
You sell. Oh, I got you. Also, story of Mt. Gox. What is that? That's certainly fair game. And how that affected Bitcoin price, that kind of crap. Okay, so the idea of solving a puzzle, the proof of work concept involving Bitcoin, certainly important. The role of mining for Bitcoin. So kind of how does the whole network work? What's the blockchain? What are miners? What's proof of work? How are new Bitcoins created? How are Bitcoins spent? Those types of things. Okay, the idea of how money is actually stored with Bitcoin, that is, how does the blockchain represent what your wallets have? So how do wallets interact with the blockchain so that you have access to your money and what is actually money with Bitcoin, that kind of stuff. So what is Bitcoin really and how is it spent? That kind of stuff. Anonymous issues surrounding Bitcoin, the fact that it's an anonymous currency, good, bad, what are the pros, what are the cons of that? Certainly, I guess Turing complete could be on there, but probably not. Probably not. Difference between mining pools and individual miners. Why would we have a pool instead of a... Why might you mine in a pool as opposed to mine individually? So reasons for that type of stuff. The concept of hashes. What is a hash as it relates to mining Bitcoins and the blockchain and validating blocks? Application-specific integrated circuits, ASICs. So almost maybe the history of mining equipment, going from CPUs to graphics cards to ASICs within SHA-256, then moving over to some alternative currencies like Litecoin, which is a script-based currency, which was trying to be ASIC resistant, but now they have ASICs for those too. So the idea of so this kind of all plays into the concept of network difficulty, which I'm sure will be somewhere here in the future, but that's certainly fair game. As the network difficulty keeps going higher and higher and higher, our equipment becomes less useful. If you have a piece of equipment that was good a year ago, it's going to be a lot less good today. All right, that's kind of the punchline of it. So because of these application-specific integrated circuits, they keep getting better and better and better and faster and faster and faster, which makes the Bitcoin network become more difficult, which makes the stuff that you paid a lot of money for 6 months ago more antiquated or completely antiquated. All right, so the idea of hashing, what does it mean? When we measure something in gigahashes, the idea that it's really just making a bunch of guesses. Concept of proof of work. Concept of a nonce. Kind of how Bitcoins are born, mentioned that a few minutes ago, but the idea that when Bitcoin first came out, 50 Bitcoins were awarded every block time, which is 10 minutes for Bitcoin. And now it's been halved, so it's like 3.25 years or something like that, the number of Bitcoins that are rewarded or awarded every single 10 minutes halves. So right now we're in the cycle of 25 Bitcoins being awarded. So cloud mining versus hardware mining, pros and cons of each. These were just some examples. Certainly there could be, so we spent quite a bit of time talking about CEX. There could be some CEX specific questions dealing with that specific cloud mining, where they support cloud mining as well as a secondary market of buying and selling gigahashes. So you buy mining power, but then you can turn around and sell that mining power. While you have it, it's mining for you. Once you sell it, it's no longer mining for you. Now it's mining for somebody else, but you made some Bitcoin as a result of selling it. So kind of that marketplace. Okay, so then a bunch of our API stuff. So the concept of a RESTful API, which uses the HTTP protocol. So RESTful API, well, these are a bunch of terms related to RESTful API. So GET and POST requests, which are HTML form requests. So GET passes everything in the URL, POST passes it as part of the HTTP request. An API is a collection of libraries for interacting with a set of data, something along those lines, abstract programming interface. SOAP is one of the standards for APIs. Before SOAP, we just didn't really have a standard. More recent standard rather, would be REST APIs or RESTful APIs. So these leverage the HTTP protocol in terms of get, post, put, and delete commands. Okay, so these are things that would definitely deem to be important. Nothing specific about SOAP, but you should know that SOAP was a standard. Specifically, RESTful APIs I put pretty high up on the importance category. Maybe something even along the lines of why RESTful APIs are based on a very old technology, which is the HTTP protocol. We consider RESTful APIs, though, to be kind of the new way of doing APIs. Why did they choose such an old technology to base it on? Something along those lines. Data representation languages like XML and more recently JSON, differences between those. Probably an emphasis on JSON. For instance, I should be able to give you maybe a collection of data. Let's just use an example. Let's see, 5 employee records and ask you to format them in a JSON document. So you'd write your employee records in there and the variables and their values. So you'd convert, Mike Littman, first and last name, phone number, email address. You convert that information into some sort of reasonable JSON representation for that kind of data. That would be fair game. And that would not count as a programming question. That's a formatting question. Okay, so kind of the difference between generic JSON as well as more complex JSON. When we dealt with generic JSON, we kind of just omitted arrays. Okay, so we have JSON is made up of JSON objects as well as JSON arrays, which are collections of JSON objects. Okay, then our payment processing solution, kind of the concept of applying the Bitcoin technology to industry. So as opposed to what we did more recently where we applied the blockchain technology. We'll talk about that here in a second. But taking Bitcoin, a currency, and replacing our current way of making payments with the Bitcoin way of making payments. And how did we determine that it was actually an improvement? And interestingly enough, just last week, Coinbase made an announcement that for applications like this, they would drop the percentages way down. way, way down. So this idea of only having 1% on either side, where we were saving basically 0.5, they said it was negotiable, but they basically want to promote people writing things like this. So maybe the entire transaction fee is 0.25% or something like that, and they're relying on it becoming really popular. So if Coinbase takes 0.25% of a zillion transactions, they're probably pretty happy, especially since they're not handling the transactions, right? They're providing an API. The transaction's on the blockchain. So what is Coinbase really doing? Well, they're buying and selling Bitcoins to you. You buy them real quick, you sell them real quick. That's what they're doing, and they're taking a transaction fee in the middle. JSON variable types it's important, but it would apply to a problem like I mentioned a minute ago, where I might ask you to format some data. The components of a block. So the block header, specifically, so for instance, I probably wouldn't ask you anything about the Merkle root. It's kind of a mathy thing. We just know it exists. Version, also relatively unimportant. The concept of why the hash of the previous block is important. The blockchain is a chain of things, so we need to know who came before me for me to validate that I belong in the blockchain. And then how the nonce plays into this. But this is the data type for our block header. The concept of script, I already mentioned that script was a competitor to SHA-256, which Bitcoin's based on, with a goal of being ASIC resistant. I mean, it had an initial goal of being a competitor, but there's a zillion alt currencies out there. But its real push was to be ASIC resistant, because what was happening, and we see it happening now, is Bitcoin is by far the most popular cryptocurrency, but the economy that supports it is in some ways getting out of hand. In order to keep up, in order to be a miner, you have to keep spending money on faster and faster and faster equipment to keep up with the Joneses. Because every single week they're coming out with, so-and-so has the latest, greatest, coolest chips, and it's back ordered, but you can give us your money now and we'll send it to you when it's ready, and who knows when that's going to be, that kind of stuff. So the idea was with script is to simplify that world by saying, this technology does not easily lend itself to specialized circuitry for doing it quickly. Now there is specialized circuitry for doing it quickly, but it hasn't caught up to where Bitcoin was yet, but the price really has scaled. So I would almost argue that it really isn't better today. If you look at script mining equipment, in many cases, it's at least as expensive, if not more expensive, than Bitcoin mining equipment. And yes, it has a slower speed, but relatively speaking, it has about the same speed. So if you pay $15,000 for a script mining piece of equipment, your power on the Litecoin mining network would be roughly equivalent to what you'd get if you spent $15,000 on a Bitcoin mining equipment, relative to that power on the Bitcoin blockchain. Okay, so this is our deals with the difficulty of the network. So we have a target, the answer we're going for. Lower the target, the more difficult it is to generate a block. Target is updated every 2016, about every 2016 blocks, every 2 weeks. So every 2 weeks we decide based on what's happened the previous 2 weeks. It's a little bit more than 2 weeks actually, but based on what's happened the previous 2 weeks, does the network have to adjust more difficultly? Or does it have to adjust up in terms of difficulty or down in terms of difficulty? And also there's an extra rule specifically with Bitcoin and anything that was based on Bitcoin that deals with what's the maximum that a change can happen in a single period of time. That way, if you have an anomaly where somebody comes up with a piece of equipment that just does something ridiculous for a very short period of time, you're not adjusting the difficulty too far in the wrong direction based on an anomaly. Okay, so then the SHA-2 standards. So Bitcoin is based on SHA-256, so this is a 256-bit hash. We have other technologies in here. You don't have to know about these technologies in terms of detail, more just that they exist, and that Bitcoin is based off of this NSA standard, okay, which is an encryption standard. Okay, so what it stands for, secure hash algorithm, kind of the evolution of it, blah, blah. I very likely would ask you to just regurgitate this slide from memory. All right, so this is kind of giving you an idea of how the SHA-256 algorithm works. There's hard-coded values here that are used to ultimately compute the Merkle root, blah, blah, blah. So if you were to look at, well, we were getting to that point, but if we were to look at the Bitcoin source code, the actual code, we'd see for every single hash that's generated, it will always start with this. This is a baseline for the Merkle root. Okay, so the algorithm will look like this type of stuff. And really any encryption algorithm will kind of look like this kind of stuff. All right, so then we were dealing with a lot of JSON stuff. We started talking about technologies involving the blockchain. So this kind of became our other side of Bitcoin. So initially we were talking about how can we leverage Bitcoin payment systems to replace credit cards. Now we're talking about forget about Bitcoin. Let's look more closely at the blockchain, the technology that these cryptocurrencies are based on, and how can we leverage that for solving some problems. Okay, so we came up with some examples. For instance, Namecoin is for DNS stuff for .bit or .io domains. We could possibly send messages with blockchain. You had a paper that you wrote involving this stuff. What we ended up looking at in here is the solution to a solution to voting using the blockchain for validating the vote count in a public way. So that's what we looked at for a while. So certainly questions involving our voting algorithm and what's strong about it, what's weak about it, things like that. So understand what we were dealing with our voting. Okay, certainly, this kind of goes back to an earlier slide, questions involving what's good and what's bad about Bitcoin. The fact that it's decentralized has pros and cons, so be able to speak to some of those. The fact that the transactions are public but still anonymous, be able to speak to some of those things. The different types of Bitcoin wallets, cloud-based versus local-based, pros and cons of each. Okay, this was kind of our model of working with the blockchain. We were using blockchain.info, their website, and they had an API. So we would have implement their API to talk to blockchain.info for creating wallets and submitting votes and all that jazz. So here was their data API. I probably wouldn't ask you anything specific about their API. I would ask more generic questions about the way we approach voting using the blockchain, as opposed to what's the outs variable for. Okay, so as we were talking about wallets, we talked about different ways we could back up our private keys related to our wallets. So, when you study the wallet stuff and when I ask a question about the wallet stuff, that kind of is going to range from, well, we can use a third-party wallet. So we're trusting somebody in the cloud to store everything for us. Or you can have your own wallet that you keep on your own hard drive. Now you're responsible for backing it up. Well, what are some ways that you back it up, and what security breaches can happen with that. How many personal hard drives do you back it up on to be safe? What if you use Dropbox? Well, now you're trusting a cloud source. OneDrive, external drive, iCloud. Maybe you just email it to yourself. Maybe you write your private keys down on a piece of paper. You can memorize it. Things like that. So these all play into the security of the Bitcoin wallet. And also maybe talk about how this stuff compares to the way we store our money, our US dollars. In a physical, wherever my wallet is, a physical wallet, in a bank, that kind of stuff. Where we're trusting ourselves with a physical wallet, right? Somebody can come and steal our wallet and we're out that money. We're trusting our bank with our bank accounts. Nothing necessarily protects us from our bank account going under. Your accounts are usually FDIC insured, so the federal government insures it up to $100,000 per person, that type of stuff. But now you're trusting the government that they'll actually pay that bill. So, who knows? So again, still with the voting problem here. We talked about the authentication problem, dealing with how much information do we need to gather in order to validate that somebody truly is who they say they are. And we looked at the way banks do authentication as an example, because one of the side effects of the voting solution deals with us making sure that the person who's voting is who they say they are. They're a registered voter, that kind of stuff. And we decided that that's not a problem we can necessarily use the blockchain in the same way to solve, but we do still need a solution for that. So then more recently we've been talking about forking the Bitcoin source code. So splitting it off and making our own SHA-256 based alt currency, where we use the Bitcoin core as the starting point and we modify variables in there to make our currency like Bitcoin but different from Bitcoin. So what does it mean to fork a repository? How does GitHub work in general? It's a SHA-256 based algorithm. Here are the variables we can control: number of coins created at each block, when does the reward have, time for a block, how often does the network difficulty change. Those are variables built into the algorithm. Bitcoin makes certain decisions, we can make different ones. Concept of the Genesis block. This is kind of the Bitcoin equivalent to the chicken or the egg problem. Bitcoin relies on the blockchain relies on at least one block. So you have to have that initial Genesis block in order to start it off. The concept of a peer-to-peer network as it relates to the blockchain. So the blockchain is not hosted by any centralized authority. It's hosted by the people who use Bitcoin or who mine Bitcoin, which is a requirement for the network. Well, how does that actually work? Last time we were talking about DNS as being a public service that's used for a whole bunch of non-Bitcoin related things. When you type in www.google.com, it translates that into an IP address. Well, as part of the DNS service, this is similar to the concept of RESTful APIs. So when these companies make APIs, they're basing it on the old HTTP protocol that has nothing to do with getting information from blockchain.info or from Coinbase or from CEX. The whole purpose of HTTP is for sending and receiving web page requests. That's it. So what they did with RESTful APIs is they said, we're going to take this technology that's been proven for years and years and years and years that has no interest in our specific, getting information out of blockchain.info, and we're going to leverage those tools so that people can request specific information from us. It was originally designed to request specific information from a web server, but we're going to replace that web server with our piece of software that sits in front of our data and serves it based on their requests using the HTTP protocol. Similar thing here. DNS is a protocol specifically for requesting the IP address given a domain name. That's its job. Well, because that's a publicly available thing that has interests all over the place, not specific to Bitcoin in any way, the peer-to-peer network with Bitcoin, if I join the network where I try to bring my my miner online, I'm going to hit the DNS server, and I'm going to request from one of the DNS IP addresses that it gives me the IP address of a peer, somebody that's on the network, so that I can join. And we talked last time about that there is a propagation delay when you first put something on the DNS servers, because you have the global servers, 5 or 6 servers in the in the cloud, and then they kind of trickle down until you have local servers, like we have one here on campus. So if somebody updates a record at the top level, it's going to take a period of time for it to propagate throughout the internet. That makes sense? But consider, how many DNS servers do you think exist on the planet at any one time? Is it billions? Is it millions? Is it thousands? Is it hundreds? What do you think? We know that the number of computers that exist in the world is probably way in the millions, right? How many of those are running DNS servers, do you think? Or how many do you suspect? Most of them? Fraction of them? How many computers do we have here on campus?
Including student computers?
Yeah. 5,000?
Yeah.
5,000 computers? How many DNS servers do we have here on campus?
1, 2.
2 that we know of. Let's be generous and say maybe there's 5. Right? A couple of students running their own DNS server, or something like that, whatever. So a fraction of the number of computers here on campus are actually running DNS servers. Do you think that this is an atypical environment, or do you think that's probably par for the course across the internet? Ish, par for the course. So most computers are not DNS servers. So are we probably talking at most in the thousands of number of DNS servers in the world? 100,000 DNS servers? I mean, you wouldn't be shocked if that was the number, right? We would be shocked if it was 100 million DNS servers. Probably doesn't make a lot of sense. So propagating a domain name across 100,000 pieces of software isn't really that big of a deal for computers. So it's not a huge time commitment, but it still does take some physical time for it to work its way through the internet. So the idea is when somebody joins the blockchain, there's a collection of peers on the blockchain that are listed as entry points into the peer-to-peer network. So when somebody queries DNS to find out where they can go to join the blockchain to latch on to one of the public nodes, that's what they get. They go to this public place, they get a real IP address, they utilize TCP/IP to get to that real IP address. Now they're on the blockchain. They're no longer reliant on DNS. As long as they hold on, they're part of the peer-to-peer network for working with the blockchain. Make sense? So that's kind of how DNS plays into that world. Okay, so I'll say that's the material that'll be covered on the final, all the way up to our discussion on DNS stuff. Go ahead.
Can you put this PowerPoint on Angel?
Is it not already on Angel?
It is? Okay. I didn't know if that was up to date or anything. But...
Oh, actually, I just put it up, right? Yeah. They just asked me to put it up the other day, or yesterday. Actually, I might have put it up this morning. But it is up there now. But I'm not giving you a refund. By the way, it was $20.
Oh.
Bitcoin. 20 Bitcoin. 5 Bitcoin. You never learned how to haggle. You get that reference?
Yeah.
Is that Family Guy?
Yeah.
Peter was haggling with somebody, and the dog was like, he never learned how to haggle. All right. Any questions on the final? Go ahead.
What would the programming be related to?
Probably something with working with an API or JSON. but not specific to JSON, maybe more like splitting a string, some of the stuff we did as part of our JSON tool. So string manipulation stuff. What else? Going once. Going twice. All right, that's it. I'll see you when I see you. Hopefully I'll see some of you next week sometime. But you'll definitely see him on Monday.